So welcome guys, welcome to another Cisco Networking Academy video. So now we're here at we will be having a summary for chapter 5, which is the Ethernet. So let's get started. So for chapter 5 we have the introduction of the Ethernet protocol, we have the address resolution protocol and the LAN switches, and also the summary. Lastly, the summary. So first, the Ethernet protocol. LLC and MAC sublayers are the most widely used LAN technologies, operates in the data link layer and the physical layer, family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards, support data bandwidths of 10, 100, 1000, 10,000, 40,000, and 100,000 megabytes or 100 gigabytes per second. So you have Ethernet standards, defined layer 2 protocols and layer 1 technologies. Two separate sublayers of the data link layer to operate logical control and the MAC sublayers. So the Ethernet uses the LLC and the MAC sublayers. LLC meaning the logical link control. Also it supports some big transmissions here, 100 gig up to 10 megabytes to 10 gigabytes per second. And for the LLC, handles communication between upper and lower layers, takes the network protocol data and adds control information to help deliver the packet to the destination. Constitutes the lower sublayer of the data link layer, implemented by hardware, typically in the computer NIC. Two primary responsibilities: data encapsulation and media access control. So the LLC is used for adding the control information and delivering the packet to destination. It takes the network protocol data to do that. For the Mac, it is implemented by the hardware, mainly the computer network interface card, and it has the responsibilities of data encapsulating data and media access control. Data encapsulation, frame assembly before transmission, and frame disassembly upon reception of a frame. MAC layer adds a header and trailer to the network layer PDU. Provides three-layer primary functions: frame delimiting, identifies a group of bits that make up a frame, synchronization between the transmitting and receiving nodes, addressing. Each Ethernet header added in the frame contains a physical address that enables a frame to be delivered to the destination node. Error detection. Each Ethernet frame contains a trailer with a cyclic redundancy check CRC of the frame contents. So MAC, responsible for the placement of frames on the media and the removal of frames from the media, communicates directly with the physical layer. If multiple devices on a single media attempt to forward data simultaneously, the data will collide, resulting in corrupted and unusable data. Ethernet provides a method for controlling how the nodes share access through the use a carrier sense multiple access or the CSMA technology. So the MAC, it searches if there's an attempt of forwarding the data simultaneously, which makes the data to be sent corrupted or unusable. Carrier sense multiple access CSMA process, used to first detect the media is carrying a signal. If no carrier signal is detected, the device will transmits data. If the device transmits at the same time, data collision. So there must not be Must not be a time where the devices transmit one at a time, because it will collide and it will make the data corrupted. Ethernet encapsulation. Early versions of Ethernet were slow at 10 megabytes per second, now operate at 10 gigabytes per second and faster. Ethernet frame structure adds headers and trailers around the layer 3 PDU that encapsulate the message being sent. Ethernet 2 is the Ethernet frame format used in TCP or IP networks. So the IEEE 802.3 is mostly the same as the Ethernet 11, but still it has different bits to follow. So for preamble in the IEEE 802.3, we have, for the preamble, we have seven bits. So for start of frame delimiter 1, destination address 6, source address 6, leg 2, 46215, and for us at frame check sequence. So for Ethernet 2, for preamble we have 8, destination address we have 6, source address we have 6, type we have 2, 46.1500 for the data, and for frame check sequence. So the difference here is the destination address and the type. But the IEEE 802.3 has more parts than the Ethernet 2, so that's why it just shares the same bits. Introduction to the Ethernet frame. Preamble and start frame delivery fields used for synchronization between the sending and receiving devices. Length type field defines the exact length of the frame's data field. Describes which protocol is implemented. Data and pad fields contains the encapsulated data from a higher layer. An IPv4 packet. Frame check sequence field used to detect errors in a frame with cyclic redundancy check. If calculations match at source and receiver, no error occurred. As for the introduction of the Ethernet frame. So MAC addresses in hexadecimal. So shown here tables of the decimal and binary equivalents of 0 to F hexadecimal. Select the decimal, binary, and hexadecimal equivalents. So for the hexadecimal, we have 0 to F. For the binary, we have the zeros and the ones, and for the decimal is the 0 to 15, which is your typical number. But for the decimal and the selected decimal, binary, and hexadecimal equivalents, we have 0 to 255, and for binary, we have 2 octets made up with zeros and ones, and for hexadecimals, we have 00 to FF. Unicast MAC address. So unicast is used for sending from the source to the destination. So here we have one desktop computer to send to the server with the other 4 devices. So there's the destination MAC, source IP, destination IP, the IP packet, and of course the whole Ethernet frame. Let's read that. Unicast IP and MAC destination addresses are used by the source to forward the packet. So for broadcast, it is used for sending the frames to multiple devices. The broadcast IP and broadcast MAC and destination addresses are used by the source to forward the packet to all hosts on the network. So they have still the same credentials needed. So for multicast, it is sending the frame in a group of hosts, but not all. So multicast IP and MAC destination addresses deliver packet or frame to a specific group of member hosts. Multicast MAC address is a Special variant begins with 01 00 5E in hexadecimal. Region IPv4 for multicast addresses is 224.00.0.0 to 239.255.255.255. MAC and IP. MAC address. This address does not change. Similar to the name of a person, known as physical address because physically assigned to the host. IP address. Similar to the address of a person, based on where the host is actually located, known as the logical address because logically assigned to each host by a network administrator. Both the physical MAC and logical IP addresses are required for computers to communicate, just like both the name and address of a person are required to send a letter. So the MAC and the IP addresses are needed for accessing the internet and also to be able to communicate with other people and devices. 5.2 Address Resolution Protocol. Our purpose: sending node needs a way to find the MAC address of the destination for a given internet link. The R protocol provides two basic functions: resolving IPv4 addresses to MAC addresses, maintaining a table of mapping. So the R uses the MAC table and searching for on how the pathway of the frame will be delivered from source to destination. So introduction to ARP continuation. I need to send information to 192.168.1.7, but I only have the IP address. I draw to the MAC address of the device that has that IP. So of course it's the 192.168.1.5 will send it to 192.168.1.7, but it only has its IP address, so it will search for the MAC address in order to be sent. The ARP functions the operation used to find data link layer address that is mapped to the destination IPv4 address. As a node receives frames from the media, it records the source IP and MAC addresses, so mapping in the ARP table. Layer to broadcast to all devices on the Ethernet LAN. The node that matches the IP address in the broadcast will reply. If no device responds to ARP request, the packet is dropped because the frame can be created. So ARP request is used for requesting the ARP table to other hosts and finding the MAC address of the destination and returning it back to the source in order for the frame to be sent. 5.3 LAN switch connects devices to a central intermediate device on most Ethernet networks. Perform switching and filtering based only on the MAC address. Builds a MAC address table that it uses to make forwarding decisions. Depends on routers to pass data between IPs and networks. Switch MAC address table. So first, they switch your server broadcast frame from PC1 to on port 1. The switch enters the source MAC address and switch port that receives the frame to the address table. Because the destination address is broadcast, the switch floods the frame to all ports, except the port in which it received the frame. The destination device replies in the broadcast with the unicast frame address to PC1. Fifth step is the switch enters the source MAC address of PC2 and the port number of the switch port that received the frame into the address table. Destination address of the frame that its associated port is found in the MAC address table. The switch can now forward frames between source and destination devices without flooding because it has entries in the address table and identify the associated ports. So this is the MAC address table in the switch. So this is the ARP, like the ARP process. So switching, we have the duplex settings. We have duplex. So as you can see, as I have explained about the wireless media, of the media in the duplexes, half duplex only send in one at a time, while the full duplex can send and receive one at a time. can receive the full duplex can send or receive simultaneously with one another. Auto MDIX auto detects type connection required and configures the interface accordingly. So once this is like a auto detection process. So if you're using some cables or connections, it will scan the interface and will configure it accordingly. So frame forwarding methods, we have the store and forward. A store and forward switch receives the entire frame and computes the CRC. If the CRC is valid, the switch looks up the destination address, which determines the outgoing interface. The frame is then forwarded out on the correct port. Fast forward switching, the lowest level of latency, immediately forwards a packet after reading the destination address. Typical control methods of switching. Fragment-free switching. Switch stores the first 64 bytes of the frame for forwarding. Most network errors and collisions occur during the first 64 bytes. A cut-through switch forwards the frame before it is entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. So we have types of layer 3 interfaces. We have the SVI, which is the switch virtual interface, logical interface on the switch associated with the virtual layer, local area network, which is the VLAN, routed port, physical port on layer 3 switch configured to access a router port. Configure routed ports by putting the interface into layer 3 mode with the no switch port interface configuration command. Layer 3 Ethernet Ether challenge, logical interface on the Cisco device associated with the bundle of routed ports. So I have here the summary. Ethernet is the most widely used LAN technology of today. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. The Ethernet frame structure adds the headers and trailers around the layer 3 BTU to encapsulate the message being sent. As an implementation of IEEE 802.2/3 standards, the Ethernet frame provides MAC addressing and error checking, replacing hubs with switches in the local area network. Local network has reduced probability of frame collisions in half-duplex links. The layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. Ethernet uses the address resolution protocol to determine the MAC addresses of destinations and map them against own network layer addresses. Each node on an IP network has both an MAC address and an IP address. An IP protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. A layer 2 switch builds a MAC address table that it uses to make forwarding decisions. Layer 3 switches are also capable of performing layer 3 routing functions, reducing the need for dedicated routers and layer 3 layers have specialized switching hardware so they can typically route data as quickly as they can switch. So that's it for chapter 5 summary, and I hope you enjoyed this video, and thank you for watching, and goodbye.